Hello everyone, I am Joglul Sarwar. Welcome to this session on AdventureWorks Database ERD Overview for the testing team. In this presentation, we will understand the database structure from scratch, explore relationships, and learn how testers can design effective test scenarios and validate data using SQL queries. To start, AdventureWorks is a sample database that reflects a real-world business environment, including sales, purchasing, and employee data. The diagram you see here represents the core entities, such as products, orders, customers, employees, and suppliers, along with the relationships that connect them. Understanding these core tables and how they interact is essential for writing accurate test cases and verifying data integrity. As we proceed, we'll dive deeper into each component, making sure you can confidently navigate and query the database to support your testing activities. An entity relationship diagram, or ERD, is essential for testers because it offers a clear visual map of how data is organized in the system. This helps you understand how different data points relate to each other, which is key when designing thorough and accurate test cases. With this understanding, you can spot potential data issues earlier and make debugging more efficient. Additionally, the ERD reveals how data flows through the system and shows the overall structure of the application. This deeper insight supports better testing strategies and helps ensure the quality and reliability of the system. AID stands for Entity Relationship Diagram, which is essentially a visual representation of how different tables or entities in a database relate to one another. Each table contains records, and we use primary keys to uniquely identify these records, ensuring there are no duplicates. Foreign keys then come into play by linking tables together, establishing the relationships between them. This makes it easier to understand how data is connected and flows through the system. For testers, ERDs are particularly useful because they reveal the underlying data architecture, helping clarify how the database is structured and supporting effective database design and testing strategies. This understanding is crucial when writing test cases or validating data through SQL queries. The AdventureWorks database is organized into several schemas, which group related tables and database objects together. These schemas help keep the database structure clear and manageable, especially as it grows in complexity. For example, there might be schemas dedicated to sales, production, human resources, and so on. Each schema encapsulates specific business areas and allows us to focus on relevant sections when creating test cases or writing SQL queries. Understanding these schemas is essential because they define how data is categorized and accessed, enabling testers to navigate the database more efficiently and target validations accurately. This foundational knowledge supports better test design and ensures comprehensive coverage of the business processes represented in the database. In this section, we focus on the production schema, which plays a key role in managing product data and inventory within the database. The products table holds detailed information about each product, such as identifiers and descriptions. Inventory tables are essential for tracking the quantity and locations of products across different warehouses or stores. The Bill of Materials table provides information about the components that make up a product, including assemblies and their relationships, which is important for understanding how products are manufactured. Finally, the Product Cost History table records historical cost data, allowing us to analyze changes in product costs over time. Together, these tables help maintain accurate and comprehensive data for production and inventory management, which testers can validate to ensure data integrity and proper system functioning. In the sales schema, we focus on key tables that manage orders and customers. The sales order header table contains detailed information about each order, including important fields like order date, ship date, and total due, which helps us track when orders were placed, shipped, and the total amount owed. The customer table links to both person ID and store ID, connecting individual buyers or store accounts, and stores vital information such as the account number for identification. Lastly, the sales order detail table plays a crucial role by linking each order to the specific products purchased, helping us understand exactly what items were included in each sale. Understanding these relationships is essential for designing test cases that validate both order processing and customer data integrity. The human resources schema focuses on the tables related to employees and their job information. The employee table holds key personal and job-related details such as national ID number, job title, and gender, which help uniquely identify and classify employees. To track salary changes over time, the employee pay history table records each adjustment an employee receives, which is important for understanding compensation trends. The employee department history table logs the departmental assignments, allowing you to see where and when an employee has worked within the company. Additionally, the shift table defines the different work shifts, outlining attributes like start and end times, which is helpful for managing schedules. Understanding these tables and their relationships is essential for writing accurate test cases and validating data integrity in the human resources module. The purchasing schema organizes the tables related to vendors and their interactions in the system. The vendor table stores essential information about each vendor, including their account number and credit rating, which helps track their status and financial reliability. When orders are placed, the purchase order header table comes into play, capturing details like the order date, expected ship date, and the total amount due. This allows us to monitor the flow of purchase orders effectively. Finally, the product vendor table acts as a link between vendors and the specific products they supply, ensuring we can trace which vendor provides which item. Together, these tables form a clear picture of the purchasing process and vendor relationships, which is important for testing order accuracy and data integrity. The person schema organizes tables that contain essential personal information. The person table itself stores key identification details like first and last names, along with a field for email promotion preferences, which indicates how the individual prefers to receive marketing communications. The contact type table helps categorize the different kinds of contacts, such as employees, customers, or vendors, providing clarity on the role or relationship of each person. The business entity table is important because it assigns a unique identifier to each individual or organization entity within the database, ensuring consistency across related tables. Finally, the email address table keeps track of primary email addresses assigned to people, which is critical for communication and verification processes. Understanding these tables and their relationships is crucial when designing tests to validate personal data accuracy and integrity in the system. Building on what we've covered about the different schemas, it's important to understand how the core tables within these schemas connect and interact. These relationships between tables form the backbone of data integrity and help us ensure accurate data retrieval during testing. For example, the products table in the production schema links directly to inventory and bill of materials tables, providing detailed product information along with inventory status. Similarly, in the sales schema, the sales order header connects orders, customers, and shipment details, creating a comprehensive view of each transaction. The human resources schema ties employee details with personal information in the person schema, while the purchasing schema connects vendor data to purchase orders. By understanding these core tables and their relationships, testers can design targeted queries to validate data consistency across multiple related tables, identify any discrepancies, and ensure the database supports the intended business processes effectively. The product table plays a central role in the AdventureWorks database schema, serving as a core component that holds essential details like the product name, product number, standard cost, and list price. It acts as a key link between various related tables, including product model, product subcategory, and inventory details, enabling smooth data flow across these areas. This table also connects with sales, purchasing, and production tables, making it crucial for integrating different business processes. Additionally, it tracks important production metrics such as safety stock level and reorder point, which help manage inventory effectively and ensure production runs smoothly. Understanding this table is important for designing test scenarios that cover product-related data interactions and validations. Sales order header and sales order detail work together through a parent-child relationship, where the sales order header contains the overall order information like the order date, status, and account number. This header essentially summarizes the entire order. On the other hand, sales order detail breaks down the order into individual line items, specifying details such as product ID, the quantity ordered, and unit price. By combining these two tables, we get a full picture of a sales order, from general order info to the specific products included. This interconnected structure is vital for smooth order processing because the system relies on data from both tables to manage and track orders accurately. Customers are connected to orders through the customer ID found in the sales order header table. This means that each customer can have multiple orders linked to them, which allows us to see all purchases made by a single customer over time. By integrating sales data, we can analyze customer buying patterns and better understand their behavior. Additionally, the system links to the store and sales territory tables using foreign keys, which helps place each order within a specific location and sales region. This setup supports tracking customer interactions more effectively and allows for tailored engagement based on their purchase history and geographic information. Foreign keys play a critical role in maintaining data integrity by linking tables through key fields, ensuring that related data stays connected. This connection allows updates to be consistently reflected across tables, which helps maintain accuracy and reliability. They also make it easier to navigate complex relational data structures, letting us trace and access related information seamlessly. By doing this, foreign keys prevent orphaned records and reduce the risk of data inconsistencies or anomalies. Additionally, they are fundamental when writing SQL queries or generating reports, as they enable proper joining of tables to pull together meaningful results from multiple sources. Understanding this role is key for validating relationships and ensuring data quality in your testing scenarios. As testers, our main focus should be on validating the integrity of the relationships between tables, ensuring that foreign keys correctly enforce data consistency, and verifying that data flows accurately across linked tables like product, sales order header, and sales order detail. It's important to check both the parent and child records to confirm orders are properly tied to customers and products. Testing should also include verifying key attributes such as product pricing, order status, and customer details to catch any discrepancies early. Using targeted SQL queries will help us validate these connections and data rules effectively, ensuring the database behaves as expected under various scenarios. This approach helps us design thorough test cases that cover both data accuracy and the relationships that hold the database together. Data relationships play a crucial role in ensuring that our data remains accurate and reliable. By defining clear links between tables, these relationships help maintain data integrity and make querying and reporting more efficient. Referential integrity, which enforces these connections, prevents issues like orphaned records and keeps our data consistent across related tables. Consistency, on the other hand, is key to reliability It helps avoid redundancy and discrepancies that could lead to errors or conflicting information. It also ensures that transactions are processed completely and accurately, preserving atomicity so that changes either fully happen or don't happen at all. This combination of well-maintained relationships and strong consistency guarantees that our database operates smoothly and that the data we test is dependable and trustworthy. Business rules are important because they make sure the data and processes we work with support the company's goals and workflows. They help define how decisions are made based on specific conditions and criteria, which is crucial for consistency and accuracy. At the same time, identifying edge cases is key to thorough testing. These are the unusual or rare scenarios that might not happen often but could cause the system to fail or behave unexpectedly. By recognizing and testing for these edge cases, we can prevent bugs and ensure the system runs reliably under all conditions. This careful attention to both the standard rules and exceptional cases builds a stronger, more resilient system overall. Validating date and time fields is essential to keep our data consistent and accurate, which helps avoid any logical errors when processing that information later. This means checking that dates and times follow the right format and make sense within the business context, like order dates not being in the future. On the payment side, validation focuses on confirming that transaction details are correct and trustworthy. This includes verifying the integrity of credit card numbers and currency values to prevent errors or fraud. Together, these checks support reliable data handling throughout the system, which is crucial for accurate reporting and smooth business operations. When you look at an ERD, or entity relationship diagram, it helps to focus on a few key elements to understand how the database is structured. Start by identifying the main entities, which are represented as boxes or tables, each containing the fields or attributes. Pay special attention to primary keys, as these uniquely identify each record in a table. Then, look at the lines connecting the entities. These show the relationships between tables. The nature of these relationships, like one-to-many or many-to-many, is often indicated by symbols on the connecting lines. Notice where the foreign keys are used. These link tables together to maintain data integrity and enable us to navigate through related data. Understanding how these pieces fit together makes it easier to write effective SQL queries and design test cases that cover different scenarios involving data consistency and validation. Keep in mind the business rules and edge cases we've discussed, because they often influence how relationships and foreign keys are implemented in the ERD. This approach helps you get a clear picture of the database's flow and how different data points interact with each other. To access database diagrams in SQL Server Management Studio, start by opening SSMs and connecting to the database instance you want to work with. Once connected, locate the Database Diagrams folder under the selected database. To create a new diagram, right-click on Database Diagrams and choose New Database Diagram. From there, you can add tables to the diagram, which helps you visualize the relationships between them clearly. This is especially useful for understanding how different tables connect and interact within the database, making it easier to plan your test scenarios and validate data effectively. When working with ERDs, using online tools can really simplify the process. These tools remove the need to print large diagrams on paper, which can be cumbersome and hard to manage. Popular options like Lucidchart and Draw.io offer user-friendly interfaces that not only let you view ERDs clearly but also provide interactive features. These interactive elements make it easier to analyze relationships and test data connections. Another advantage is how simple it is to share your diagrams with team members, promoting better collaboration. Just make sure whatever tool you choose is compatible with your existing databases to avoid any integration issues as you work through your testing scenarios. Now that we've explored how to view the ERD and some critical validation checks, let's focus on designing test scenarios based on the ERD itself. Understanding entities, their attributes, and especially the relationships between tables helps us identify key areas for testing. For example, we can create scenarios that verify the integrity of foreign key relationships, ensure data consistency across linked tables, and validate that business rules like mandatory fields or unique constraints are enforced. We should also simulate edge cases like missing data or invalid inputs within connected tables to confirm that validations hold true across the database structure. Using the ERD as a blueprint allows testers to systematically cover data dependencies, ensure all workflows are reflected properly, and catch potential anomalies early in the testing process. This approach not only strengthens data reliability, but also supports more targeted and effective SQL query validations. To maintain relationship integrity, we need to define tests that ensure the connections between tables are accurate and consistent. First, we verify that there are no orphan records in the sales order detail table, meaning every order detail should have a related record in the sales order header. This means checking that all order details link back to existing headers. We also need to test the constraints between sales order detail and the product table to confirm that every product referenced in the order details actually exists in the product list. Additionally, we ensure that all records align properly with valid sales order ID values, preventing any invalid associations. Finally, we validate the cascade delete and update actions to make sure they work correctly. This ensures that when a sales order is deleted or updated, the related order details adjust accordingly without leaving inconsistent data behind. These checks are crucial for preserving the integrity and reliability of the relational database. To maintain foreign key integrity, it's important to validate that the customer ID always refers to an existing customer record, ensuring no references to non-existent customers. Similarly, each product ID must be verified to confirm it exists in the product table. Before entering any new data, we need to check that all related records are already in place to avoid orphan references. Monitoring for cascading events is also essential, as these help keep data linked correctly when changes occur. Finally, when importing data in batches, reviewing foreign key constraints thoroughly helps prevent integrity issues and preserves the overall consistency of the database. To maintain data consistency, it's important to ensure that order total calculations are accurate. This means validating that the total due field matches the sum of the individual order details. We also need to check that this total aligns with the subtotal, taxes, and any freight charges. When discrepancies come up, they should be identified and corrected as soon as possible to prevent any impact on reporting or processes. Automating these consistency checks with scripts helps keep this validation ongoing without manual effort. Finally, all findings and any adjustments made should be carefully documented to create an audit trail, which is essential for traceability and compliance. This approach helps keep the data reliable and supports overall quality in our testing process. When validating dates in the order process, it's important that the order date comes before or at least matches the ship date and due date. This helps maintain a logical flow through shipping operations, avoiding situations where shipments appeared to occur before the order was even placed. Keeping this sequence intact not only supports smooth operational efficiency but also makes tracking shipments clear and accurate. It also reduces the risk of errors that could cause delays or issues in fulfilling orders, which is critical for maintaining reliable service. Checking this date sequence is a key part of ensuring the data is reliable and the processes run as expected. When validating payment amounts, it's important to first check that the total due calculation is accurate, so it reflects the correct sum of all charges. We also need to make sure that total due never goes below zero, as a negative amount would not make sense and could cause issues. Cross-verifying these totals with the invoice details helps ensure consistency across the records. This step is critical because it maintains financial and accounting integrity, ensuring the data is trustworthy. Ultimately, thorough validation here prevents billing errors and potential disputes with customers, leading to smoother transactions and better trust in the system. When testing CRUD operations, we start by checking the create function to ensure new records are added correctly without any issues. Next, we focus on the read operations, making sure the data retrieved matches what's stored and displays accurately. Then, for update operations, we verify that changes to existing data are applied properly and that no unintended data is altered. For delete operations, it's important to confirm that records are removed cleanly without errors or leaving behind orphaned references. Throughout these steps, maintaining data consistency and integrity is crucial. So we always verify that the entire CRUD cycle keeps the database reliable and accurate. When testing join operations, it's important to confirm that multi-table joins return accurate and meaningful results. This means ensuring that the relationships between tables actually follow the defined referential integrity rules, so no mismatched or orphaned records slip through. We also need to verify that the join queries produce the expected data, matching what the business logic requires. Additionally, performance should be checked to make sure join queries run efficiently without unnecessary delays. Lastly, thorough testing helps catch any incorrect data relationships early on, preventing logic errors that could affect downstream processing or reporting. All of these steps together help maintain reliable and consistent data interactions across the database. It's important to make sure that all fields marked as non-nullable actually have values. This prevents any missing or incomplete data from entering the database. Along with that, checking constraints such as unique keys ensures that we don't have duplicate values where they shouldn't exist, and validating foreign keys helps maintain correct relationships between tables. By enforcing these constraints, we protect the integrity of the data so it remains accurate and reliable over time. This kind of validation is essential for maintaining high data quality, which supports consistent and dependable results in testing and operations. Before we process any sales, it's crucial to confirm that all products involved actually exist in the database. For each sales order detail, we need to verify that the product IDs referenced are valid and correspond to existing products. Similarly, the salesperson entries in the sales order header must be checked to ensure they are accurate and relate to real salespeople. Purchase order details require the same level of validation, making sure each product ID they include is legitimate. Finally, the customer references in the sales order header should be thoroughly validated to confirm they correctly represent the actual customers involved. These checks are essential to maintain data integrity and avoid errors in transaction processing. To effectively validate the data and relationships we've discussed so far, we use SQL validation queries. These queries help confirm that our data meets the defined business rules, constraints, and integrity checks we outlined earlier, such as ensuring correct payment amounts, accurate CRUD operations, proper joins, and non-null constraints. Writing targeted SQL queries allows us to retrieve and inspect specific data points, verify cross-table references, and flag any discrepancies or anomalies early on. This approach ensures that the underlying data adheres to expected patterns before it's used in reporting or further processing, giving us confidence in both the accuracy and reliability of the database. When checking for orphan records, we focus on identifying sales order detail entries that are missing their parent references, like a missing sales order ID. This can happen if the parent sales order record was deleted or never created, causing data inconsistencies. To find these orphans, we use a left join between the detail table and the parent table. This join lets us spot detail records where the matching parent doesn't exist by returning null values in the parent columns. Once identified, it's important to clean the data either by correcting the missing references or removing the orphan records altogether, ensuring the integrity of relationships and overall database quality. To ensure the financial data is accurate, it's important to validate the subtotal recorded in the sales order header against the total we calculate from the details in sales order detail. By using SQL queries, we can recompute the subtotal by multiplying the unit price by the quantity for each order and then summing these amounts. This helps us identify any discrepancies between the recorded totals and our computed values. Once we find any mismatches, we need to investigate and resolve them promptly to maintain reliable and consistent financial records, which is crucial for accurate reporting and auditing. We need to identify any instances where the sequence of order date, ship date, and due date is incorrect. The key rule here is that the order date must always come before both the ship date and the due date. Using SQL, we can compare these dates to validate that they follow the correct chronological order. When we find any discrepancies, it's important to highlight these errors so they can be corrected, ensuring that the entire process complies with the expected business rules and maintains data integrity. This step is crucial to prevent issues that could arise from impossible or illogical date sequences in the order processing workflow. In this check, we focus on identifying any missing customer ID values in the sales order header table, which holds critical transactional data. The customer ID acts as a foreign key linking each order record to the customer table. If any sales order header records lack this customer ID, it signals a data inconsistency that could affect order tracking and reporting. To find these missing entries, we use a simple SQL query that selects sales order ID where customer ID is null. This helps us pinpoint records that need attention, ensuring the integrity and accuracy of our sales data. In the sales order detail table, each line item represents a product sold in an order, and it's crucial that the product ID for each line item exists in the product table. If there are invalid product ID references, meaning product IDs that don't match any entry in the product table, it can cause problems during order fulfillment because the system won't be able to link products to the details properly. To identify these invalid references, we use a SQL query that selects the sales order ID and product ID from sales order detail where the product ID is not found in the product table. This helps us catch any orphaned product references early, ensuring data integrity and smooth order processing. Total due represents the amount a customer needs to pay for their order, so when we see values that are 0 or negative, it usually signals a problem. These values are often incorrect because an order should have a positive amount due. This kind of issue can arise from mistakes in pricing or from discounts being applied incorrectly. To find these errors, we use a simple SQL query that selects sales order IDs where the total due is less than or equal to 0. Identifying these helps us catch and investigate potential data or business logic problems that might affect billing or reporting accuracy. In this part, we focus on detecting duplicate records within the sales order detail table. Duplicate entries here can cause sales figures to be overstated, which affects the accuracy of reporting and analysis. The main fields to check for duplicates are sales order ID, sales order detail ID, and product ID, as these uniquely identify each sales detail line. Duplicates might appear due to system glitches or manual entry mistakes. To find these, we use an SQL query that groups records by these fields and then looks for groups where the count is greater than 1, indicating duplicates. This kind of validation helps ensure data integrity and prevents inflated sales numbers in your reports. When working with joined tables, like sales order header and customer, it's important to ensure data integrity by verifying that every entry in sales order header has a matching customer ID in the customer table. This helps prevent orphaned records, which occur when a sales order header entry refers to a customer ID that doesn't exist in the customer table. To check this, we can use a left join in SQL, joining sales order header to customer on customer ID, and then look for cases where the customer ID on the customer side is null. For example, the query shown retrieves sales order IDs and their corresponding customer IDs where no matching customer record exists, effectively identifying orphaned records. Running this kind of join validation ensures our data remains consistent and reliable for analysis or reporting. When approaching data validation and testing, it's important to adopt a tester mindset that focuses on being thorough, curious, and detail-oriented. You want to think beyond just checking if something works and instead ask why something might fail, where errors could hide, and how data inconsistencies can impact business decisions. This means understanding the relationships between tables, recognizing key data points like foreign keys and primary keys, and anticipating edge cases such as missing or duplicated records. It also involves verifying assumptions, validating joins carefully, and being skeptical of unexpected results like negative payments or invalid references. With this mindset, you aim to uncover issues early, ensure data integrity, and deliver reliable feedback that drives quality improvements across the database and application. When identifying breakpoints, it's important to first recognize where critical data interactions occur, because these points often have the greatest impact on system behavior. We need to evaluate how the system performs under stress to ensure it can handle peak loads without failure. Checking the consistency of data integrity is also key, so we validate that data remains accurate and reliable across processes. Testing efforts should focus on the more complex entities within the system, as they tend to have intricate relationships and higher risk of issues. Finally, it's essential to explore possible failure scenarios extensively, so we can foresee where things might go wrong and develop test cases that address those risks comprehensively. This approach helps us prioritize our testing effectively and maintain confidence in the system's stability. When dealing with missing data, it's important to first identify the areas where data is most likely to be absent. Once those areas are clear, you should implement checks specifically designed to detect null values within the database. A useful approach is to simulate scenarios where datasets are incomplete, which helps us understand how the system behaves under such conditions. This is critical because the business logic needs to manage missing data without causing errors or unexpected behavior. Testing with sample databases can also provide valuable insight into the real-world impact, showing us how missing data might affect overall functionality and decision-making processes. This careful handling ensures that the system remains robust and reliable, even when some information is missing. When validating relationships in the database, it's important first to confirm that foreign key constraints are set up correctly, as these enforce the links between tables. Ensuring data integrity across these relationships helps prevent orphaned records or mismatched references. Pay attention to the types of associations, especially one-to-many and many-to-many, to verify they behave as expected in the system. It's also crucial to check that updates to key records cascade properly through related entities, so changes remain consistent throughout. Finally, don't overlook the integrity of historical data tables, which often rely on these relationships to maintain accurate audit trails and past transaction records. This thorough validation helps maintain reliable connections and consistency across the database. When checking calculations, it's important to start by verifying the basic arithmetic operations used in reports to make sure all sums, averages, and other computations are correct. Next, pay close attention to calculated fields to ensure they reflect the right formulas and logic. Financial data requires another level of scrutiny, so take time to reassess aggregations and summaries for accuracy. Currency conversion is another key area. Check that exchange rates are applied correctly and consistently. Finally, test the calculations against boundary conditions to confirm the system handles extreme or edge cases properly, which helps catch potential errors before they affect real data. We've covered a lot of important points about testing database systems. It's crucial to adopt the right mindset to anticipate potential issues and identify breakpoints where the system might struggle or fail, especially with complex data interactions. Handling missing data carefully by simulating different scenarios helps ensure the application manages incomplete datasets correctly without breaking business logic. Validating the integrity of relationships between tables ensures data remains consistent, particularly when foreign keys and cascading updates are involved. Finally, checking calculations in reports and summaries is vital to maintain accurate and reliable outputs, including critical areas like financial data and currency conversions. Keeping all these aspects in mind will strengthen your testing strategy and help you uncover hidden issues effectively. Entity relationship diagrams are essential tools that help us understand and manage the database structure clearly. It's important to validate the database schema practically, which ensures that the design works as intended and helps catch issues early. Using SQL queries plays a critical role in testing by allowing us to retrieve and verify data efficiently, supporting thorough validation of relationships and calculations. Lastly, we have a rich, comprehensive dataset that covers key business areas like sales, production, and human resources, giving us a wide range of scenarios to explore and test effectively. Working directly with the AdventureWorks dataset helps reinforce the concepts we've covered by giving you practical experience. Using a standardized dataset like this one allows you to build and sharpen your testing skills in a consistent environment. This approach not only deepens your understanding, but also enhances your ability to solve real-world problems you might encounter during testing, making your work more effective and reliable. For further support, you can refer to several helpful resources. There is an installation video that guides you step by step through setting up the AdventureWorks database, which is great if you want a clear visual walkthrough. To build your SQL skills, online tutorials offer comprehensive practice on a variety of query types, helping to deepen your understanding through hands-on exercises. Community forums are also valuable because they provide a space to discuss questions and find solutions from others who are working with similar challenges. Lastly, you can explore detailed documentation and sample files available on Codeplex, which offer extended opportunities to practice and refine your skills beyond this session. These resources together will strengthen your ability to validate data, understand relationships, and confidently write effective SQL queries. Thank you all for your attention and participation throughout this session. I hope the overview of the AdventureWorks database, the exploration of entity relationships, and the practical use of SQL queries have given you useful insights for your testing work. Remember, understanding the data structure and validating it carefully helps ensure the quality and accuracy of your testing outcomes. If you have any questions or want to revisit any part of the presentation, feel free to reach out. Wishing you success in applying these concepts to your projects.